Hello everyone. Welcome to the solution of LeetCode problem 2870 named minimum number of operations to make array empty. Here we are given a zero indexed array nums consisting of positive integers. Now there are two types of operations that we can apply on the array any number of times. In one operation, we can choose two elements with equal values and delete them from the array. And in another operation, we can choose three elements with equal values and delete them from the array. Now, we have to return the minimum number of operations we need to make the array empty, or otherwise we have to return -1 if it is not possible. Now, let's consider the first example. Here we can see that the array has the element 2, 3, 3, 2, 2, 4, 2, 3, and 4. Now, in one operations, we can make this element 2 and this 2 empty, or we can remove this element 2. So here, after next operations, we can remove these 2 and these 2. So all of the 2 have been removed. Now, in one another operations, we can remove these 2 3s and these 3s. And in the final operation, we can remove these 4 and these 4. So total, we are using 4 operations to make this array empty. So in this problem, we have to return 4. Now, in the second example, we can see that the array contains 6 elements, which is 2, 1, 2, 2, 3, and 3. Now, in one operations, we can erase these 2 and these both of the 2's. And in another operation, we can erase these 2 3's. But this 1 cannot be erased by using any of the operations. So here, it is not possible to empty the array. That's why we have to return -1. I hope you understood the problem statement. Now, the array length can be in between 2 to 10 to the power 5, and each of the array element can be in between 1 to 10 to the power 6. I hope you understood the constraint. Now let's move on to the algorithm. Now, let's try to understand the algorithm by using this first example. Here in the first example, we have 4 2's. One here, another is here, another is here, and another is here. We have 3 3's. One is here, another is here, another is here. And we have 2 of the 4, one is here, another is here. Now, we can make these 2 4 empty or erase these 2 4 by using one operations. Now, we can erase these 3 of the 3's by using one operations, and we can erase these 4 2's by using two operations. So here, we need in total of 4 operations to make the array empty. Now, at first, let's try to understand in which case we cannot be able to make the array empty. There are only one case in which we cannot make the array empty if any of the element in the array has the frequency of 1. And the basic intuition and the basic algorithm of this problem is if any of the element of this array has the frequency of 1, in those kind of cases, we cannot erase those elements which has the frequency 1. Otherwise, if any of the element has the frequency greater than 1, we can always remove all of them. Suppose one element has frequency 2. So in one operation, we can remove 2 of the element. Suppose one has frequency 3. Here, one operation is needed to remove all of these 3 elements. Suppose another element has frequency 4. In this case, we need only 2 of the operations. In first operation, we can remove first 2. In the second operations, we can remove the second two element. Suppose any of the element has frequency 5. In those kind of cases, we need also two element or two operations to make the array empty. In one operations, we can remove 3 of the element. In another operations, we can remove the remaining 2 element. Similarly, if any of the element has frequency 6, in those kind of cases, we need 2 of the operations. In the first operations, we can remove the first 3 element. In the second operations, we can remove the next 3 element, and so on. So here, you can examine that for any of the integer greater than 1, by using the first or second operation or by using both of them, we can always make the array empty. But unfortunately, if any of the element has the frequency 1, it is not possible for our algorithm to make the array empty. So now, let's try to understand what is the minimum number of operations. So here, for each of the element, we have to calculate their frequency, and we have to divide the frequency with 3. Or we can say that we can calculate the modulus of the corresponding frequency and the 3. If the modulus of corresponding element with the element 3 is 0, then we can make frequency divided by 3 operations. So now here we have to think the algorithm greedily. As in one operations, we can remove 2 of the element or we can remove 3 of the element. We should always try to remove 3 element. And if in any of the cases we cannot able to remove 3 element, in those kind of cases only we have to try to remove 2 of the element. So here, removing 3 of the element has higher priority. Now, so that's why we are performing the modulus operation with the frequency and 3. And if the frequency is strictly divisible by 3, suppose in this case, which is 6, here we have to divide the frequency with 3. So here 6 divided by 3 will be 2. Now, if the modulus is 1, suppose for this element 4, the modulus of 4 and 3 will be 1. So here we need 2 operations. So 2 operations will be 4 by 3, and we have to perform the scaling operations. So here it will be 1 point something, and if we scale 1 point something, then it will become 2. So here it will be scaling of frequency by 3. Now, it can be possible that the remainder of frequency and 3 will be 2. And in those kind of cases, it is also the frequency divided by 3 and after the scaling operations. Suppose for this element 5, here the 5 modulus 3 will be 2. So here the minimum number of operations will be 2. In first operations, we have to remove 3 of the element. In next operation, we have to remove 2 of the element. So here, if the remainder will be 2, then the equation will be frequency divided by 3. And after that, we have to perform the scaling operation with this divided value. So here, the algorithm is pretty simple. Finally, we have to calculate the frequency of each of the element, and we have to calculate these operations or this equation, which is the corresponding element divided by 3. Anyways, let's understand this algorithm by using the first example. Here in the first example, the frequency of 2 is 4, the frequency of 3 is 3, and the frequency of 4 is 2. So here, if we divide 4 by 3 and perform the scaling operations, it is 2. And if we divide 3 by 3 and perform the scaling operations, it will be 1. And if we divide 2 by 3 and perform the scaling operations, it will be 1. So in total, there are 4 operations to make this input array empty. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named minimum operations, which has a vector as a parameter. Now we are initializing the variable answer with 0 and end with the array size. Now we are declaring a map, and here we are calculating the frequency of each of the input elements frequency with the map. Now here we have to iterate each of the element or each of the entry in the map, and we have to check whether the frequency is 1 or not. If the frequency is 1, then the answer will be -1. In these kind of cases, we cannot make the array empty. So we have to break the loop. Otherwise, we have to perform the scaling operations. That means we have to divide the frequency by 3 and scale the corresponding value. So the equation will be frequency plus 2 divided by 3. After that, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the element of the input array. And the space complexity is also big O of n because we are using an extra map to store the frequency of the corresponding element. That's why in the worst case, the space complexity is big O of n, where n is the size of the input array. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.